Ladies and gentlemen, it's really a great pleasure for me to be able to present my university, Aalto University, here and participate to the panel discussion. Aalto University was established 10 years ago, 2010. At that time, 3 universities were merged: Helsinki University of Technology, University of Art and Design, and Helsinki School of Economics. This made a very unique combination of science and art, technology and business. Aalto is a foundation-based university, and we have the endowment of 1 billion at the moment, and this of course gives us a bit more flexibility in this field. The founders of Aalto University were, besides the State of Finland, Confederation of the Finnish Industry, academic engineers and architects, and also the alumni from business school. When Aalto was founded, we got the national mission to strengthen Finland's innovative capacity through first-class research and education and also art. And we are committed to building a sustainable society driven by innovations and entrepreneurship. We are now in Otaniemi in our campus area, and at the moment all our students and all our activities are placed here in Otaniemi. The campus has developed a lot. I hope you have a chance to walk a little bit around so you can see the change. On the daily basis, we have here in this campus area about 12,000 students. Our staff is about 4,000, from which 400 are professors. Aalto has also become very international during the 10 years' time. About 40% of our academic people are international. If we look the graduates from Aalto 2018, more than 260 doctors were graduated from here, as well as more than 1,600 masters. I am coming from the School of Chemical Engineering. I started there as a dean about 1 year ago. My own background is also from this school, so like as I said, we studied at that university some years ago, and during that time I have to say the school has changed a lot and the university has changed a lot. Currently we have 3 different departments. We have focused our research in 3 different areas, which are bioeconomy and especially materials bioeconomy, circular economy, and there we especially focus on material circulation, but also on circulating textiles and plastics. And the 3rd area includes advanced materials, and there we focus on materials especially for energy capture and storage. In Aalto we have altogether 6 different schools. 4 of them are technical schools, and School of Chemical Engineering is one of those. It's the smallest one. We have full-time students, about 1,000, from which 135 are doctoral students. We have employers about 500, and as FTAs calculated about 400. Totally we have at the moment 43 professors. And if we look how we can affect to the change and what is our role as a university to sustainable bioeconomy. Universities, so the role of university is to educate the future changer makers or game changers, as we say in Aalto. This education is based on high level, high quality research and science. Our students, they are the ones who need to solve the grand challenges in the future, and these challenges are very complicated and complex in many ways. Therefore, the solutions need to be multidisciplinary. In the area of bioeconomy, for instance, we need good knowledge in chemistry, biochemistry, biotechnology, process engineering, automation, digitalization, economics and financing, but also in design. And because we have the School of Arts in our university, we promote collaboration between the different disciplines. Chem Arts is a very good example of this type of collaboration. And in Chem Arts, the students from chemical engineering and art and design school work together. They first had summer schools, then the collaboration developed, and at the moment we can offer a minor course module to everybody who are studying in Aalto. And this picture here is a very good example of the collaboration of our students, which they made for Helsinki Design Week in September. And the designers, they designed these items, and the chemists and chemical engineers, they designed the nanotechnology surface shown here. So there is a lot of technology behind, and of course a lot of design behind. And the experts, the material experts, they said that they've never seen this type of shining surfaces made from something something organic material. So this is a fantastic example, and this is all cellulose, and it's also biodegradable. So fantastic examples of collaboration. In education, we also emphasize sustainability. We are currently building the strategy for Aalto University. It will be launched in January, and sustainability is very important in our strategy. We want to include that in all education, in all our research, and also to our campus development. We have obtained also feedback from the industry that there is a great need for specialists who have specialized in sustainability questions, but there is also a need for everybody working in the industry to have the basic knowledge on sustainability. We also provide continuous learning, so that is in a high in our national agenda here in Finland. We are living in a rapidly changing world, like just heard. It's very important every now and then to update the knowledge. The new ways of learning, digitalization for instance, will provide also possibilities to do distance learning and education. The other very important task for the universities is to carry out research and science, research and development. In the universities, we can tolerate more risk in our research, and we can also and should also focus on basics and fundamentals. But it's very important that all our professors and researchers understand what is the connection of the basic research to applications and innovations. There we need close collaboration to the industry. So alone the universities are not making the innovations, so that's a close collaboration with the industry. We have a very good example in the research working together with the industry and transforming basic knowledge to industrial innovations. The flagship program, which we started last year, it's FinSERES, called FinSERES flagship program, and it's a collaborative program together with VTT and financed by the Academy of Finland. It's a long-term project altogether for 8 years. and there we focus, for instance, to the future applications. I think somebody mentioned here today energy capture and conductive materials made from nanocellulose. So those are, among the others, the subject which we have studied in that flagship program. As I mentioned, Aalto is a university focusing on innovations. Therefore, we also promote entrepreneurial activities. In this campus area, for instance, we have a startup center called A-Grade. It hosts startups, more than 140 startups, and it is not just a collection of startups, it's also a platform where different people can meet, so the students, startups, and also people from the industry. So they can meet, they can discuss, and they can generate new ideas. We also have, especially related to bioeconomy, we have a very modern infra. During the last 4 years, we have invested in Aalto more than 6 million euros to our bioeconomy infra, and we want to develop that in the open policy type of systems. Now then, about the challenges, what do I see? What are the biggest challenges, especially in the area of bioeconomy? So I consider the availability of raw materials for the increasing applications quite challenging. In materials bioeconomy, wood-based materials, there are lots of interesting opportunities, and there are also a great need to replace the fossil-based materials, like many plastics, for instance. But we need to ensure that we have availability to the raw materials. At the same time, our forest, it has also other roles. It's very essential in climate change mitigation and also conserving biodiversity. But I'm convinced that these different roles can be combined. Sustainable forestry, forest management, tree breeding, for resistance, and also sustainable use of the raw material where no wastes are produced, but instead different types of value-added products are generated. So these are the ideas and issues to ensure the resilience and vitality of our forest, and also to ensure that our forests are the foundation of the growing bioeconomy. Then a few words about the other challenge I picked up here. I'm a technologist from my background, so that's why my challenges are also reflecting my background. I also see that challenging that in the future we can develop more sustainable and competitive processes for bio-based products. And especially here, I mean the fractionation technologies with which we can fractionate the different main components from biomass. Still a lot to do, challenges to engineers and for all of us. I thank you for your attention.